What if I told you that one of the brightest stars in the night sky nearly convinced the entire world that it was about to explode? That astronomers held their breath. Social media panicked. Headlines screamed doomsday, and yet the real explanation turned out to be even more fascinating than a supernova. Because what Betelgeuse revealed was not just how stars die, but how alive they really are. For centuries, humans have looked up at the constellation Orion and noticed a red glow marking the hunter's shoulder. A star so bright, it feels close. Our most personal in that star is Betelgeuse, a red supergiant, so massive and unstable that it represents the future of our own sun written. On a much larger and more violent scale, Betelgeuse is not an ordinary star quietly burning hydrogen in balance. It is a stellar giant nearing the final chapters of its life, swollen to an unimaginable size, so large that if it replaced our sun, it would engulf the orbits of Mercury, Venus, Earth, and Mars, stretching almost to Jupiter. A cosmic monster breathing heat, light, and energy into the surrounding darkness. Astronomers have long known that stars like Betelgeuse are doomed to explode. Not gently fade, but collapse and rebound in a cataclysmic supernova that for a brief moment can outshine entire galaxies, forging heavy elements and scattering them across space, seeding the universe with the building blocks of planets and life itself. Because of that, Betelgeuse has always been watched carefully, studied obsessively, treated like a ticking cosmic clock whose final moment could arrive at any time within the next 100,000 years, which in cosmic terms is the blink of an eye. Then in late 2019, something happened that nobody expected. Something that made even seasoned astronomers uneasy, because Betelgeuse began to dim rapidly, losing nearly 60% of its brightness in a matter of months, becoming visibly fainter to the naked eye, something that had never been recorded in modern astronomical history. Red supergiants do pulsate, they do change brightness slightly, but this was different. Dramatic, sudden, and unexplained. And almost immediately, whispers turned into speculation, and speculation turned into fear. Because one of the earliest warning signs of a supernova can be sudden instability in brightness. Telescopes around the world pivoted toward Betelgeuse. Observatories scrambled for observation time. Researchers compared notes across continents. And the question echoed everywhere from scientific journals to late-night talk shows. Is Betelgeuse about to explode? The idea captured the public imagination because this would not be a distant, invisible event. This would be a cosmic spectacle visible from Earth, potentially bright enough to cast shadows at night, visible even during the day, a reminder that the universe is not static, but alive and violent. People asked if Earth was in danger, if radiation would harm us, if the sky would permanently change. And while astronomers reassured everyone that a supernova at Betelgeuse's distance would be safe, the excitement and fear didn't fade. Because for the first time in human history, we might witness the death of a massive star, with modern instruments watching every second. But then, months passed, and Betelgeuse didn't explode. It didn't collapse. Instead, it began to slowly brighten again, as if nothing had happened, leaving behind a mystery even more unsettling than the idea of a supernova. Because now astronomers had to explain something that didn't fit existing models. If Betelgeuse wasn't dying right now, then why did it dim so dramatically? And what did that say about our understanding of stars? For years, the mystery refused to settle, with competing theories suggesting internal pulsations, temperature changes, massive star spots, or deep structural shifts inside the star's core. But none of them fully explained the scale and speed of the dimming. Then, new data arrived, and this time it wasn't just brightness measurements. It was something far more detailed, far more revealing. A combination of space-based telescopes, interferometry, spectroscopy, and long-term monitoring that allowed astronomers to see Betelgeuse not as a single glowing point, but as a complex, dynamic object with texture, motion, and weather. What they discovered changed everything, because Betelgeuse hadn't dimmed because it was collapsing inward. It dimmed because it had expelled a colossal amount of material from its surface. A violent outburst that sent hot plasma blasting into space, where it cooled, condensed, and formed a massive cloud of dust that temporarily blocked the star's light from reaching Earth. In other words, Betelgeuse didn't fade. It was covered like a cosmic fog rolling in front of a lighthouse, making it appear weaker, when in reality it was as powerful as ever. This was the first time astronomers had directly observed a red supergiant, ejecting material on such a scale and then watching that material condense into dust in real time, confirming long-standing theories about how massive stars lose mass before they explode. The dimming event was not the death of Betelgeuse, it was stellar weather, a gigantic stellar sneeze that briefly hid the star behind its own debris. And when the dust dispersed, the brightness returned. But this explanation, while relieving, was also deeply unsettling, because it revealed just how unstable and violent Betelgeuse truly is, with a surface dominated by enormous convection cells. Regions of rising and falling plasma so vast that each one could swallow our entire solar system. These cells churn, boil, and collapse, sending shock waves through the star's atmosphere, occasionally ejecting massive plumes of material into space, slowly tearing the star apart from the outside in. This new data showed that Betelgeuse is not quietly waiting to die. It is actively shedding its outer layers, losing mass in unpredictable bursts, and every one of those bursts brings it one step closer to its inevitable supernova. And here's where the story becomes personal, because everything around you, the calcium in your bones, the iron in your blood, the oxygen you breathe, was created in stars like Betelgeuse, forged in nuclear furnaces and scattered across space by stellar explosions. Betelgeuse is not just a mystery in the sky. It is a reminder of where we come from and where the universe is going, because the same processes that will one day destroy it are the processes that made life possible in the first place. The new data also helps astronomers refine their models of stellar evolution, improving our ability to predict how and when massive stars explode, not just for Betelgeuse, but for red supergiants throughout the universe. Stars that shape galaxies, trigger star formation, and influence the cosmic environment on massive scales. Yet despite all this progress, one truth remains unchanged. Betelgeuse will explode someday. Not as a threat, but as a spectacle. A cosmic farewell that will briefly remind humanity of its place in a vast, dynamic universe. When that happens, Earth will be safe, but the night sky will be transformed, with a new point of light rivaling the brightest objects we know. A reminder that even the stars are temporary. Until then, Betelgeuse continues to pulse, to breathe, to shed itself layer by layer, teaching us that stars are not static balls of gas, but living systems with cycles, storms, and outbursts, far more complex than we once imagined. The real mystery was never why Betelgeuse dimmed. The real mystery was why we ever thought stars were simple, predictable, and calm, when the universe has always been chaotic, creative, and violent. Thanks to this breakthrough, astronomers are no longer just guessing about the lives of red supergiants. They are watching them change in real time, turning the night sky into a laboratory and Betelgeuse into a teacher. So tonight, if you look up and see Orion rising, remember that the red star marking his shoulder is not fading away. It is preparing, shedding its skin, rewriting our understanding of stellar life, and waiting for a moment that may come long after humanity is gone, or sooner than we expect. Because the universe never follows our time. And that leaves us with one final question. Not about Betelgeuse, but about ourselves. If we misunderstood something so bright, so visible, so familiar, what else in the universe do we think we understand but don't? What other cosmic giants are quietly changing beyond our notice? And how many secrets are still hidden in plain sight, waiting for the right data, the right moment, and the right question to finally be revealed? Comment what you think Betelgeuse will do next. Like this video if space mysteries fascinate you, and subscribe to AED ID, because the universe is never silent. It's just waiting for us to learn how to listen.